Welcome to Computer Vision Decoded, a podcast about the quickly evolving world of computer vision. As always, today I'm going to be joined by our co-host Jared Heinley, the chief scientist at EveryPoint. And today we have a special guest, Keith Ito, the founder of Scaniverse, a 3D capture app for iPhones. Keith will be sharing with us the evolution of the Scaniverse app and the challenges that he faced with building an app for 3D capture. He's going to dive into the nitty-gritty of balancing speed, performance, and quality of output in a 3D capture app. We're also going to talk about the challenges of building an intuitive interface for end users. He's also going to share a bit about the future of Scaniverse as they're now part of Niantic. Let's jump into this episode and decode what it means to build a 3D capture app on an iPhone. Welcome to the show, Keith and Jared. Really excited to have you here, Keith. Talk about Scaniverse and maybe just a little bit about the background of your career leading up to building this excellent 3D reconstruction app. So, can you just kind of give us a quick background of like what brought you up to Scaniverse in your whole entire experience working with like 3D data? I know that you prior had experience at Google Maps, in other places. So, could you start out just giving us a little bit of background about you there?
Sure. Yeah. First of all, thank you for having me on the podcast. I'm super excited to be talking to both of you. As far as my background goes, I think I started out pretty much straight out of school going to work on Google Maps, and this was kind of in the kind of mid 2000s. It was just kind of like a really exciting time to be working on maps and at Google. I think when I got there, Google Maps was only launched in the US and the UK. So the rest of the world was just like a giant blue ocean without even any land there on the map. And so I worked on while I was there, I worked on the map tile rendering side of things. It was mostly 2D graphics, but taking all of this geographic data that Google was either licensing or collecting itself, and turning that into a map of the world that you could kind of zoom in pretty much as far as you wanted, and or zoom out to see the whole world. And I think that's kind of when I first started getting really interested in this idea of being able to map the world and to be able to take data and turn it into something that you could share with people, or that people would find useful. And so I was there working at Google Maps for a while, and at some point in time, I think it must have been around maybe 2008 or so, 2007, 2008. I think maybe Apple had just announced the iPhone. Android was kind of gaining steam, and you can kind of see this big transition toward mobile kind of on the horizon there. And kind of at that point, I kind of moved over to start thinking about, how, well, first of all, how maps would work on a mobile device, but also like how you would do like a cloud first like navigation service. So like back then, if you wanted turn by turn navigation, maybe you would buy like a Garmin, or one of those standalone GPS units, and stick it in your car, or maybe your car would have one built into the dashboard. But the data would usually be a little bit out of date, right? You'd have whatever it came with, or maybe you could get updates.
Yeah.
They'd be like once a year or something. And
If you even took the time to do it, I know many people who would buy Garmin and never update.
right, yeah. And so the idea of it being cloud first was something that Google could do, because and that could really only be done like once you had this device in your car that was like constantly connected to the internet. And so you could update the data, you could update, but you could even get more granular than that, right? You could have real-time traffic, and then also update the route that the user would take based on current traffic conditions, and things like that. And so so that was also like like a really interesting experience to have to work on this product that was taking it really reinforced to me like the importance of keeping your map up to date and keeping the data that you're collecting up to date. And then it also was I think one of my it was when I first started my obsession with like getting the most possible performance out of like a mobile device because back then things were not as performant as they are now, and even just you really had to optimize and kind of think ahead of time like how you were going to optimize everything to even just be able to render it like 30 FPS on a device. So
You can
yeah.
almost see that in the trajectory of how you've taken Scaniverse. We'll get to that, but just how it's like you made it work, and is if you almost followed your Scaniverse blog, you could see, you weren't finished with each update. You're like, no, we're not done here. There's much more we can do, and so I'm excited to kind of talk about that little optimization path you took. But
Yeah, definitely. Like I think yeah, like like you're basically never done with optimization, right? Because there's always more. There's always more you can do, right? And whether it's especially in like scanning or reconstruction, because you can always make it faster. You can always bump up the resolution, right? You can get more detailed. Like it's kind of like it's a really interesting problem because you're basically never done. And but so yeah, I think it was kind of around that time that yeah, I really realized that, and it can be a lot of fun to optimize stuff. Especially if
Jerry could talk about that too. I mean, it's like when you're stuck with a problem, you'll take a fun break and optimize our back end and make it somehow faster.
It's fun for that variety. Like you're saying, being able to work on these hard problems, but how do you do navigation and and mapping, of the world, but then also make it go really fast. And so it's the algorithms as well as just that engineering effort to make things performant and easy to use.
Right,
Such a fun mix.
Yeah, it's almost like a game, right? Because you usually have some metric that you're trying to optimize for, and then you try something, and then that time goes down or your FPS goes up, and then you're just trying to find different things that you can do that will raise your score, basically.
And that's what's helpful to talk to your clients or talk to your user base. Be like, well, would you put up with taking twice as long to get a 3D model, but it'll be much better quality? And some people say, I don't mind waiting, or some people who just say, no, I need it like right now. So just finding that limbo of where do you optimize for speed, quality.
Right. Yeah.
Ideally, you hope you get both.
Yeah. Hopefully you can get both. Yeah. Eventually. Yeah. And or maybe some people want one and some people want the other, and you need to kind of offer both. But yeah. So I guess getting back to my background, kind of after that, there was this other project that was just spinning up inside of Google. It was it didn't have a name yet, but it was what eventually became Google Glass, and I hadn't really done anything in like AR up to that point, but they needed someone to kind of bring some of the mapping and navigation pieces over to Glass, and so because I'd worked on that before, they kind of asked me to do that, and that Glass was a really interesting project and an interesting product. I think it was probably a little bit before its time, both in terms of what the hardware could do at the time, and in terms of people's perceptions, like in terms of like what what people thought of AR at the time. It was very there wasn't much of a basis to go on for people what people had used before, and so like on the hardware side, right, a lot of the display and optics technology maybe wasn't quite there yet. Although you could see it on the horizon, right. But you just and a lot of the stuff that's coming out now, right, with this kind of renewed interest in AR and mixed reality, is it was kind of on the horizon back then, but just tantalizingly like out of reach. And but we learned, or I learned a lot about what it takes to build experiences in AR, and what it takes to kind of develop a product on new technology that is where the hardware is still being developed, and the software is still isn't written yet, and nobody knows what the UX should be, or so it's
it's kind of the problem that Magic Leap ran into as well. They're trying to define what this new, I mean, maybe it's not new, but really new to consumer technology is, and a lot of people say, "Oh, I don't know."
Right.
That to be honest, probably one of my favorite gadgets or devices I've gotten the last couple of years was the Ray-Ban Stories, because just having that camera on my face while I'm playing with my kids, like, the last thing I want to do is like, hold on, I'm gonna pick up my phone. I could care less if the quality of the images were not as good as my iPhone 13 at the time, but I caught it in the moment and I didn't have to stop what I'm doing. So I think there is something still in that form factor, but like you said, it's still very new to the thought of having overlays on your face and all those things that just, we've all kind of done a pretty good job at optimizing the iPhone and Samsung, all these great Android interfaces that everyone's used to, versus this is all new on the face.
Right. Yeah. It's all new on the face. It's something that's obviously very obvious on your face, and I think it's something that will take some time to get used to. But yeah, like you were saying, like the ability to capture something while you're in the moment, the ability to get information when you need it, or to augment the world in kind of interesting ways is, I think. I think it's a really promising technology for the future.
Mm-hmm. All right. Well, let's pivot, because we really are excited to have you on the show to talk about Scaniverse,
right?
Which I'm assuming most people who tuned in have heard of this app, but out of all of the 3D scanning apps that have been on an iPhone, it's by far one of my favorites. I don't want to say it's like the number one, because I know there's other great apps that are slightly different than it, but it has definitely been, from a usability standpoint, I mean, it has been great. I love it. But can you just kind of, for the people who maybe have never heard of Scaniverse, can you give people just kind of like, what is this app? Just a quick overview.
Yeah, I mean, so Scaniverse is an app that lets you kind of capture, edit, and share the moments, the things, the places, and the people that matter to you. So the way it does it is, it's an iPhone app where you can just go around, scan something. It can be basically anything, and then it will reconstruct a 3D mesh out of that for you, and then allow you to, you can share it in messages, you can share it on the web, you can share it to sites like Sketchfab, and let other people experience it, either in 3D, in AR, kind of in whatever format they want to experience. And so kind of the way I think of it is kind of every I guess every medium for sharing has its own corresponding capture technology. Like, kind of, if you think of, like, I don't know, like paper or like 2D sort of things, like you had photography for that, and then we got these screens that can show like videos and multiple images in succession, and that really drove like video capture. And now just on the horizon, or even today, right, we have VR, and on the horizon a bunch of like interesting AR and mixed reality technology coming out. And people, I think, are really going to need some way of easily capturing stuff in 3D in order to fully engage with those platforms. And that's kind of where Scaniverse fits in.
Yeah, totally. I like that, because it's like we live in a 3D world, and so having efficient tools to capture that world, and share it with others. So maybe just a good little just to make that more specific. I mean, like, so what inspired you to build Scaniverse? how did you decide you want to tackle that space of how do I document my 3D world?
Right. So I mean, it was kind of an app that I wanted to have for a long time. Like going back, I used to do some photogrammetry, where you would basically the workflow for that is, or at least back in the day, it was you would go and take your DSLR. You'd go take a bunch of photos of something, maybe 100 or 200 photos. You'd copy them to your desktop computer, and then you'd let it kind of crunch overnight while it was processing them into like a 3D model. And sometimes it would work great, and you'd end up with like a really great 3D model in the morning when you woke up. But sometimes you would make a mistake when you were capturing, or the object just wouldn't work very well for the capture, and so the next morning you'd go and the geometry would be wrong, or maybe it would just fail completely. And so one thing I always wanted to have was something that kind of made it a lot easier, where you could capture and process directly on your device. You could get the model back, in about a minute or so, and so you would immediately know while you're still there that something went wrong, and do it again. And just something where that was kind of more tolerant, maybe, of user error, or that guided you while you were capturing to have to know what you've captured, to know what you still needed to capture, so that you could get a better scan, and have more confidence that your model would turn out. And so this was something that I had wanted to exist for a long time. And if it did exist, I would have been, I would have gone out to the App Store or whatever, and been like its biggest power user. But it didn't at the time, and so I kind of set out to build it. And I think one thing that came along that really was really quite helpful, or quite amazing, really, is that when Apple announced that the iPad would have a LiDAR sensor, right? I think that was in, gosh, was that
2020?
Yeah, I think
2020 iPad Pro.
2020 iPad Pro. That's right. Yeah, and all of a sudden it was like, wow, you can have this technology that used to. It used to be like LiDARs used to be like this, standalone rig, and you'd have to, carry it around and stuff. And to think that they, are making this kind of standard equipment on the iPad Pro is just incredible. And then later on that year they brought it to the iPhone, and it was at that point that I realized that this could really be a platform that you could do like really good 3D capture on, and it's just this thing that sits in your pocket, which is just it's amazing how fast like technology develops, and how all of these things that you thought were either impossible or years away were just show up one day, right? As a software person, right? It's really great, because like like Apple and Google and all these other, Samsung and they're all it's almost like Christmas, right? when they do a big announcement, and you find out that there is all this stuff to play around with and to build software for. So.
It's been interesting watching GPU technology as well, where someone asked me one time, should I get the RTX 2080 because the 3080s are out now, but I know that the 2080s are, I can get them for a better deal. And I'm like, you don't understand, like, this technology is not just getting incrementally better. Some of this technology is like 4 times, 5 times better. And that's what the GPUs were doing. It was like, if you went back a model, you weren't just half as good, you were like a quarter as good. And I'm seeing that even with the iPhones and the smartphones from Samsung. The computational photography is able to do on it. It's like it's just incredible, So I always say, like, just buy the best smartphone you can afford, and that's going to be amazing. So
yeah, it really is incredible. People say that a smartphone is like a supercomputer in your pocket, and it turns out it really is. I was actually looking this up the other day, and like an iPhone 14 can do something like 2 teraflops on the GPU, right? And if you go back and if you look at the top supercomputer lists, they have these lists that go back in time. And if you go, the iPhone 14 would have been the top supercomputer in the world in 1998. So if you can like, I mean, and these things, they cost hundreds of millions of dollars. They took up a whole room, and now to think that you can carry around something with equivalent like compute power in your pocket is just absolutely insane. And like 1998 isn't that long ago, right? I remember 1998.
Even just more recent, it's just amazing, like just the raw power, like single-threaded performance. It's like, okay, I've got a desktop PC that I do my development on, day to day on, and there, like, oh, if I got some single-threaded code, that desktop PC versus the iPhone, it is like head to head. It's amazing, how fast, the computation is on the, modern smartphones.
Yeah, definitely.
Mm-hmm. And then just putting all those it's not just like single threaded processors, and then put those performance processors, and then they put just different ones geared for, hey, I want my phone to stay charged for a longer period, so you can optimize for that, and not say, oh yeah, well, we'll get this really fast, but your phone will be dead in the next 30 minutes. They've really done a good job and all the manufacturers are doing that now. So yeah, it's so I guess then talking about when this app first came out, it's not like if you download it today, the app that you see today it looks very similar to the original app that came out in was it 2021 or 2020?
It was the very end of 2020, like December.
So that app only supported the LiDAR, correct? It was
That's right,
just for LiDAR. Can we? So I think there's a lot of we could go really deep into the LiDAR on an iPhone. There's still a lot of debate. Is it a LiDAR? I'm not worried about that. I think what people care about is like not what it is, but what it can do. And as I always say, people who are in the LiDAR community will say, well, this isn't true LiDAR. I don't care. All I know is it gets me depth data, and that's really all you really are looking for. But can you tell me? Can you speak about kind of like what were the pros and cons of using that LiDAR? Is there some things that like a headache of using the iPhone LiDAR, because it is not the same as a terrestrial LiDAR? Can you speak about that, of like how's that been helpful, but also you wish things were a little different on it, perhaps?
So I mean, the biggest pro of it is it's this thing that's built into this device that you're carrying around all the time, and so it's always with you, and you don't have to think about it. You just pull out your phone and start capturing. I think it's an amazing technical achievement that they managed to get this into a consumer device that everyone can carry around with them. I guess on the other side is that they had to make, I think, a number of kind of compromises in order to get it in terms of in order to get it to be a small size and lightweight and not draw too much power, and also be inexpensive enough that you can make it a standard feature. And so I think some of the drawbacks are that it's fairly low resolution. So the depth maps you get back from the the depth API are 256 by 192. So they're tiny. They're like postage stamp size things. But it turns out that even those are actually kind of generated by Apple using a neural network from about 500 individual depth readings on the frame. And so they, I think they take the color image and they take their kind of depth readings, and then they pass a neural network over it that will kind of essentially fill in the gaps between the depth readings so that you get a nice depth map. And while that works, surprisingly well, like a lot of the time, sometimes because it's a neural network, it hallucinates things. Like if you see like an object, it might be unclear whether it's part of the foreground or part of the background, right? And and it might get it wrong some of the time. So you do have to be like, if you're using this sensor, you have to be a little bit careful to be tolerant of that sort of error. It's a very different error from a typical sensor where there might be like noise in the sensor, but you can accumulate over time, like multiple samples, and that should, if your noise is kind of distributed around the actual value, it'll average out over time. With the iPhone's depth maps, because it's hallucinating, it could very confidently hallucinate stuff on multiple frames, and that will just end up there. The other interesting thing is that I think you can also end up with some systematic error in the LiDAR readings. So again, like if it's just noise, you can average that out and that goes away. But if it's, say, consistently predicting that something, or consistently telling you that something is, say, 3% or 5% farther out than it is, then that can create problems too, especially because if you're looking at if you're using like the poses, for example, from the camera positions from ARKit, like as you move around something, those poses are all calculated based on like visual features in the scene, which is it's kind of like a different system from the LiDAR. So you have these kind of two sources of data, the visual features and the LiDAR, and you're trying to combine the two, and that can be kind of difficult because they have completely different like error characteristics. So, and I see Jared nodding his head because I know he's probably dealt with a lot of these problems as well.
Yeah, Jared, you want to add to that?
Oh, I was going to say, I mean, that's a great point. Your distinction there about the two different sources of error, saying like, the LiDAR is going to have its own set of structured errors based on that neural net's output, or the limitations of the sensor itself, and then with ARKit, and then it's doing the pose estimation using those visual features. Yeah, that's going to be a different error. That's going to be maybe like long-term drift, or so when you go and try to generate, sort of a fused, 3D understanding or fused sort of 3D reconstruction of that scene. Yeah, you've got these different errors, sort of local, maybe structured errors from LiDAR, plus sort of the long-term error, or different kinds of error from that ARKit data, that pose data. Yeah, that's a good point.
Yeah, and I know I've kind of gone deep on the kind of negatives of LiDAR, but it's actually an amazing sensor. Like especially it kind of complements what you can do with photogrammetry a lot. So if photogrammetry won't work on like flat surface, textureless surfaces like a wall, right? But the LiDAR works great on that, and so in a lot of cases you can kind of use it to fill in the gaps that are not working well with photogrammetry. And then of course it's also you're instantly getting back these depth readings. You don't need to do any computation before using the depth, and so it's great for like live visualizations and things like that.
Yeah, that live feedback. And you mentioned that earlier, talking about just the benefits of having that live feedback and not having to wait till you get back home, run some photogrammetry software overnight and just crossing your fingers and hoping that it works. Having that live feedback when you're in the field, when you're like, if on your vacation, you're only going to be at the museum, you're only going to be at the beach for a certain amount of time, and you want to capture that scene, capture that memory, or if you're an inspector doing an inspection of a bridge or, a building, it's like you may have just driven a few hours to get to that location to do the inspection. So having that real-time live feedback is super, super critical and really, really nice. And so now that's I love how you ran at that problem and are providing people that feedback and the quick processing there on device to get those results.
Yeah, for the people who may be watching this on YouTube as opposed to just listening, I'm sharing on my screen where you have this kind of like red cross. It's not crosshatch, but this red covered area on an image, and that goes away as you capture an object. And I think there's a lot of instant gratification when you're scanning something. You're seeing it come to life, and you have that confidence. Okay, well, at least I saw it. It's car's pretty easy to cover, but I try to do a whole room, and you're like, okay, did I get that corner over there, or did you get behind or between things? that feedback's magic.
Oh, it's amazing. It's amazing. I absolutely love that feedback there. Just, yeah, you see, as you start to scan things, you see it just come into, full color, where everything else is sort of just kind of, hidden there in the background and red. As you were, thinking about creating a 3D scanning app, what were some of the hardest parts of designing that experience, designing that app to make it easy to use so that anyone can just pick it up, and do a great 3D scan?
Yeah, I think a lot of the challenge was around people. Most people haven't 3D scanned anything before, and trying to communicate to people, like how to scan and what sort of motions. I know you guys did the whole video on like good motions for reconstruction, but how to communicate that to people, not just in words, but also in through the UI and through the feedback that you're getting as you scan was like a big challenge. Like you would, I think when you just hand like a phone to people and say, scan something, maybe the natural inclination is just to stand in one spot and do a lot of panning around. But then, if you do that, you don't get a whole lot of baseline, right? So it's hard to do like photogrammetry based on that. And so, you really want to encourage people to go around and scan the thing from all angles. And I think, I think having a UI where it's kind of fun to make parts of the scene disappear, appear out of the striped area is one way of doing that. I think just kind of making it so that you don't have to think about what you're capturing as you're doing it, or what the right technique is, and just being able to have that come out of the experience, I think is really important, and that's something that that I spent a lot of time on, like iterating on different things until one that I found one that seemed to work with people. So
yeah, no, that's impressive.
I'd say what really resonates with me and the struggles of having a good app experience to get people to do the best practices, to model something to their best ability, is that Apple almost ruined it for us by making this such robust visual tracking system for the LiDAR that you can literally stand in the middle of the room and get a somewhat sane 3D reconstruction of a whole entire room and not really move besides whatever arc your hand's taking with the phone. But that's the wrong thing to do if you want to get a really good quality scan. So, how do you say, well, that worked, but that's not what I want you to do in the app. So, even Room Plan, if anyone has heard of Room Plan, where it gets you basically the primitives of the room, you get like the wall shape, you get like a room layout. At first, I was trying to walk around the room, and it was like, no, you can just stay there where you are and just sweep your hand across the room, and it catches all these visual anchors. It just works. And I was like, oh, this is dangerous, because again, we're teaching people to stay in one spot to make a 3D model, and that's not going to help you if you want to get that good quality. So good on Apple for making it work, but also has its own set of unique challenges now for someone. So okay. So with that, then talk about you added detail mode. I'm looking at your blog. So like in 2022, like a little after a year after you had launched this, you added detail mode, where you added actual photogrammetry besides the LiDAR. Was that a challenge, just to also say, okay, now you have to actually walk around an object? I will share on my screen again too, just like a shoe you had from detail mode, and it's striking how much more detail you get. But of course, that's only if you do something correct.
Definitely. Yeah, I think it is a challenge to get people to really walk around the model. Like to a certain extent, showing the stripes helps, because you'll see like around the corner that there's still stripes over there, and be able to come to the other side. But yeah, it's interesting that you do kind of want people to capture things a little bit differently for LiDAR versus photogrammetry. And in the future, I think the capture you do for nerfs will be also a little bit different, because there, you get all the view dependent lighting effects, and so you really need to get even more views, or views of the scene from different directions, so that you can get all of that, all the different like specular highlights and things like that. So I think it's an ongoing challenge to like both like educate people on how to actually capture, but also building out the UIs that encourage them to capture in kind of the right way, or the way that will yield the best model.
And I think about nerfs. One of the magic of a nerf is you get all the context of everything behind the object that you captured. So you say, okay, well, we have an object and it's also in this location. But when you're teaching someone to say model an object with photogrammetry, you're usually telling them fill most of the screen up with that object, because everything behind it's not going to help you unless it's, you're trying to use those as visual anchors. But now with the nerf, I'm like, tell people stand further back. I want to see the scene. And it's just, yeah, you're right. Each little mode is different. So LiDAR from an iPhone is different from photogrammetry and nerf. So how do you have a UI that tells everyone what to do in the right time? That's where I think augmented reality, those AR overlays, will be very helpful as well, that Apple's added for like room plan. It'll say, move your camera down, find a corner, adding some guided visuals in the app in the future could be very helpful.
Yeah, definitely. I think, more active guiding of people to areas that they haven't scanned, or that maybe they don't have enough viewpoints of a certain area. Just being able to call that out to the user, being able to encourage them to go to that spot, because you'll get a better reconstruction if they go and do that. I think these are all like really kind of interesting and exciting, like open challenges. Like how do you do that without without being like annoying, where it's like, okay, now where you're like kind of commanding the user, now do this, now do that, now do this, right?
Well, you took the Magic Leap template, and I think now the Quest Pro that I have does it, where they almost gamify trying when they map out your room, and it's kind of like hide and seek. Go find the next hidden anchor in the room, and by doing that, you're moving to the areas that haven't been mapped by the unit, and so it's kind of fun. And then it's mapped like, oh, I completed something,
right?
So how can you gamify this? Give them something engaging.
Definitely.
Yeah, and it is a value, like you mentioned there. Yeah, just the guiding someone to go through a space and then adapting that for the particular technology or for the particular application. Saying, oh, I just need to map my room. That might be a different motion pattern than, oh, I need to map the objects on the tables in the room. And then so just having those different experiences, or like you even said there, like with the nerf versus the LiDAR versus the photogrammetry, each of those are going to have their own sort of subtle differences. It's nice understanding that common technology in the background, the underpinnings of, well, how does photogrammetry work? How does nerfs? Oh, nerfs need poses from photogrammetry. Oh, okay. And so understanding that technology, influences those solutions. But yeah, like you were saying, Keith, with the LiDAR and just adding in those visualizations to help guide the user and turn it almost into a game, saying, oh yeah, I see a little bit of red over here. Let me go over there and get rid of all the red in the scene, until I've captured that object that I've want. It's a fun experience. So continue. I mean, maybe it's continuing the line of thought. Okay, you mentioned detail mode. I've heard you now Scaniverse supports non LiDAR devices as well, doing pure image-based photogrammetry.
That's right. Yeah,
that's awesome. So how did you achieve that? What were some of the limitations or challenges of running an image-only photogrammetry pipeline on a mobile device?
Yeah, I mean, I think the biggest challenge was just taking a photogrammetry pipeline, can be very complicated. There's a set of stages where you do feature detection, so you're kind of finding landmarks in the image. You match them. You figure out where all the poses are, where all the cameras are. You do bundle adjustment to refine. There's a whole. You do depth mapping and then the meshing. So there's a whole large number of stages that you kind of have to squeeze down a little bit to fit on a mobile device. And with modern mobile device, like we were talking about earlier, it really is almost like a supercomputer in your pocket. So that makes it easier. But there still are limitations in terms of like how much RAM is available and how much and just how much work you can do in a short period of time. I think another challenge is that whereas it might have been acceptable to run a photogrammetry pipeline overnight, like on your desktop computer, if you told someone just leave your phone here, for a few hours and it'll be done, most people wouldn't be too happy. I mean, if their battery even lasted that long. So just figuring out like which trade-offs to make in order to get the pipeline to run in say about a minute or so or less was kind of like one of the biggest challenges, and like figuring out like what is actually important for quality, and what what do people care about in terms of the model, and then also just like a lot of like I think we were talking earlier about optimization, right? And going just really deep into optimizing things, and uh, uh, getting speed ups that way. Like it's really interesting that you often think about or as a programmer you often think about like the algorithmic changes, or like big O notation, right? To where you're making these like very large changes to make something faster. But I found that oftentimes it's these little tweaks or just figuring out how to fit something into the cache, or figuring out how to move some computation from the CPU to the GPU and parallelize it in that way that can often make like huge differences in terms of performance. And so it's it's a really fun process, I think, and it's also something that you're never done with, right? If we could make certain steps in the pipeline faster, we could maybe increase the depth resolution or increase the number of the amount of detail in the mesh, and so you can kind of go as deep into optimization as you want, or as time permits, right? I think if I had infinite time, I might just like sit in a room and just optimize until the end of the world or something. But there's obviously always other stuff to do. So
Yeah. I mean, and that's I totally agree with what you said there. I mean, it's like, yes, a lot of times people may think of, you said, oh, I need to change the algorithm. But it's like we said, well, okay, yes, and yeah, maybe you can change the algorithm, but then you hinted on, it's like, well, what changes to the algorithms can I make that aren't, are still going to achieve the detail and the quality that I need? If at some point, if I say, oh, I can just reduce the number of feature matches between my images, at some point you're going to have too few feature matches, and you're going to lose connectivity, between those images. And so there's certain trade-offs there to the accuracy and quality. But then, as you said as well, there's just, also just coding and engineering things that, make better use of the cache, make better use of the hardware and the parallelism. Those tweaks too. That is a lot of fun.
Right. And of course, there are algorithmic changes you can make as well. I don't want to make it sound like
no, but I'd say, but I think both are very, very equal and valid. There's a lot of times, and using my own code, I'm optimizing the reconstructions performance. Yeah, there's algorithmic changes where I'm like, oh yeah, instead of n log n, I'm using a linear algorithm instead. Or I'm going to use a slightly different method that is a bit faster, in terms of its computational complexity. But then there's also just a whole host too of engineering, tweaks that, like you said, you can just spend quite a long time finding ever more ways to make that code more efficient.
Yeah, and then I always like to take the viewpoint of the non-scientist, non-engineer, and say, how can we train a user to be more efficient in capturing? Because you take twice as long to capture something, have twice as much footage to work with, and that might be not ideal. So, there's that. How do you, I guess, engineer an augmented overlay that guides someone through a scene efficiently or around an object, make sure they capture just enough, but not too much. So
Yeah, definitely. Yeah, I think yeah, it's interesting how like the UI or UX kind of plays in with everything else, right? You know, it's especially as an engineer, you often think about the algorithms and you know, and how you're going to write the code, but I mean, equally important to achieving performance is like how do you guide the user to do to kind of capture things in an optimal way so that you can do it efficiently. So yeah, definitely.
Yeah. Well, you know, I did not keep you too long. I did wanted to ask you a few more questions. So, what are your thoughts on the future of this? Do you of 3D scanning in general of your app? I mean, you don't need to tell us what you're working on next, but you know, where do you see this going? Because to be honest, iPhones and LiDAR and 3D capture is actually pretty new on a mobile device. Stockpile reports that we run, we've been doing that for a long time, but it's always been sent to the cloud. This is like new that we actually have on device. You don't have to send anything up. Where do you see that future? Is it new hardware? You guys going to be putting on smart glasses, perhaps? I mean, where do you see this going?
Yeah,
As an industry as a whole, not necessarily even your app.
yeah, I think it's like a super exciting time because, like you said, like being able to, you know, capture and reconstruct on a mobile device is like very new. In terms of like the fidelity of capturing stuff, that's also moving very quickly. Nerfs came on the scene relatively recently and are just advancing really rapidly. There are other just ways of improving. Of getting just improving the depth mapping, constant advances in being able to generate depth maps better, of being able to um, just create more accurate and visually appealing scenes. And so I think, uh, and I think we're actually just getting started on that front, right? If you look at like photos and videos, those have been around for a long time, and they're still making advances there in terms of like computational photography and like stabilization and things like that. Uh, but on the 3D side, it's very new, and so I think there's a long road ahead of just improving fidelity, improving quality, making it easier to capture stuff. I think. Like we were saying earlier, right? The educating the user or getting the user, finding some sort of user experience that allows the user to generate a good capture quickly every time is really important, and so there's a lot of work in that area. And then finally, I think just being able to it's great to be able to capture something, but really it's what do you do with that capture, right? How do you share it with people? How do you uh, uh, kind of take what you've created or what other people have created and kind of mix those up and create new content and share experiences and kind of create this meaningful stuff in your life in 3D. And uh, I think for a long time, 3D content creation has been really hard. You needed to have certain skills in terms of like modeling stuff or being able to actually create stuff that look good. I think again, it's a really exciting time, not just for 3D capture, which is getting better every day, but also in terms of like generative AI to generate 3D models or to be able to construct scenes for you out of out of just text, for example. It's I think we're on the verge of this really like exciting time in 3D, and in addition, right, all this display technology is coming out too. We have VR headsets now that are actually pretty good, and in terms of like AR and mixed reality, I know Apple is coming out at some point with their mixed reality headset, and so I think all these things play together and are kind of working together to create this really exciting 3D ecosystem that maybe a few years down the road will we'll all be able to experience. So.
Yeah, no, it's an exciting time. It's an exciting time, like you said. Yeah, the convergence of hardware and software and machine learning and vision and cameras and sensors and displays. There's so much cutting edge things happening in all those fields, and then the convergence of that is awesome.
Yeah, definitely.
So one thing we didn't talk about, and I don't know if you want to, it's up to you if you want to talk about it, but I know about a year and a half ago, you joined Niantic, and all of a sudden this app became free for pro users. That is another amazing thing, is the quality of the app you've built, and it's free. It's not like these photogrammetry software that used to cost thousands of dollars, and so can you talk about that alliance, or am I gonna be able to scan objects and then have it in a Niantic game or experience? Is that a future? Is that something you can even talk about?
Yeah, I can definitely talk a little bit about that. For people who might not know, so Niantic is is kind of a maker of AR games, probably best known for Pokemon Go. But what people might not know is that Niantic is also building like a very detailed map of the world. So the thing about like their games like Pokemon Go is that you're not playing just in this virtual world, you're playing out in the real world, right? It encourages you to go to places in your community or to new places, and to walk around and explore the real world, and to play at those places. And so part of being able to bring gameplay everywhere is like building like a really detailed 3D map of the world. Like I was talking about Google Maps earlier, and you might have streets and businesses there, but we're talking here like down to the centimeter level, so that you can if you're at the park or something, that this is a bench right here, and this is a fountain or whatever. And so a while back, kind of early on in Scaniverse's life, I was focusing mostly on, how do you capture stuff in the real world and create this digital copy of it? And they were like, there's also this other aspect of it. You can kind of think of it as like maybe a two-way street, right? Where on one hand, you want to take stuff that's in the real world and create a virtual copy of it, but you also want to take this digital stuff that you have, whether it's content that you've scanned or content that you've created, in 3D modeling software, and bring it out into the real world and have experiences with other people that center around that content. And it turns out that scanning is kind of important to both sides of that equation, right? So if you're capturing stuff, you're capturing it by scanning, but if you're trying to get content into the real world, your device needs to know what that world looks like. And so you need to be able to have this like centimeter level virtual map, or map of the world, so that that when you place the content here, it's going to stay there. And if someone else comes and wants to look at it, it'll be in that location. And so one of the things that Niantic is building that is super exciting is this Lightship VPS, which is a visual positioning system. So it's taking basically the entire world and mapping it down from scans at kind of like a centimeter level of accuracy. And that's what really enables a lot of this content placement. It's going to be, or it is available to developers now, so that if you are building your own game or your own 3D experience or AR experience, you can kind of leverage all this work that Niantic's done to be able to take this map and just place your content there, and to build like immersive AR experiences that that your users will enjoy, and that'll be really fun and exciting, and that are actually tied to real places. All right, so I think with VR and AR, it can be it can be very easy to get into this state where you're kind of just immersed in your own world and not paying attention to the world outside of you. And I think what makes Niantic's approach to this exciting and different is that it really seamlessly tries to blend the real world and the digital world together into this one space where like everybody is. So.
Mm-hmm.
And so yeah, so getting back to how Scaniverse fits into this picture, we're providing the scanning piece to that is it's going into the Lightship platform. So it's kind of Niantic's developer platform for this. So if you're a developer, you can scan objects or you can scan areas to map them for BPS and kind of use the same engine as Scaniverse to do that. And that's in beta right now. It should be launching later on, pretty soon actually. And then in addition, we're pushing forward with Scaniverse and developing new features because it is just a really great way to to figure out like we were saying earlier, like what the right UI for scanning is, and to get people to how do people to figure out like how people want to share content and how people want to use the scanning technology. And so we're kind of going forward on both fronts, and it's a really exciting time to be doing all of this.
All right. Yeah. No. I think people should look into that Lightship VPS system as well. I think that is going to have a lot of implications for the 3D world moving forward. I personally feel, and some of us at our company feel that the augmented reality world, that mix of real and virtual, is going to be more of our future than this virtual reality world, which has its place as well. But I think where we're going to see most advances or most, I would say, world-changing things are going to be that mix of what you're scanning in the real world and placing it in the real world, interacting with it in the real world, because it's a more social thing. I can see, sometimes I don't get it, and then my kids are like, check this out, check out this AR thing. It's like, well, they're really into it, so I know that's what they're growing up with and can expect from a 3D world. And so I know they are leading the way at Niantic with that, and Pokemon Go is a great example of that, 3D mixed with real world and maps and everything. I love geospatial 3D. It's all there. So
right, yeah, it's really interesting, like how all these different like technologies are coming together to like create this experience that like hopefully like we'll all be able to share together.
And they're capturing all our imaginations with games, and that's again also, I think entertainment's going to be the key. We can get applications running in industrial plants and manufacturing, and industry 4.0 is the term, but that's not going to capture everyone's hearts and imaginations. It's going to be through games and entertainment and sports or whatever it is, and that's what Niantic, I feel like, has done so well is, hey, let's make this fun for everyone and show them what's possible, and then eventually it'll bridge into more of your life.
Yeah, definitely. Like finding the fun and getting people engaged is like that important first step, because I think a lot of times people might not understand technologies until they've used it themselves, and they've used it in an experience that is really meaningful to them. And so I think in a lot of ways, games and just social aspects of things are like a great way to kind of get things in people's minds so that they can expand later to these other contexts.
Yeah. Well, Keith, it's been great having you on this show. I just want to also ask if people want to keep up with what you're working on. Would you suggest people follow you personally on a Twitter or some social platform, or how can people keep track of what you guys are up to? Or is Scaniverse's website where to go?
You can visit the Scaniverse website at scaniverse.com, or follow us on Twitter. We're just at Scaniverse on Twitter.
That's easy. And I'll make sure we link those in the show notes for people to find. And of course, you can find the app easily by just searching Scaniverse in the App Store. And like you said, it's free now, right? So have fun with it. You don't even need a LiDAR, which is exciting.
That's right.
So thanks a lot, Keith. Thanks for joining us as well, Jared. I know your insights are valuable because you've also spent a lot of time working in the world of mobile-based 3D reconstruction. And it's fun to have you guys as pioneers on here paving the way. With that, thank you for coming.
Yeah, and thanks for having me on.
Yeah, thanks, Keith.
Well, that's a wrap. I hope you enjoyed this episode where we talked to Keith Ito about building Scaniverse and the challenges of building a 3D capture app on an iPhone. You can find all our past episodes on the EveryPoint channel. You can also find the video version of this episode on all major podcast platforms. I want to extend a special thanks to Keith Ito for jumping on this episode and talking about building his app, Scaniverse, and what future lays for 3D capture apps in general. I also want to thank Jared Heinley for providing his valuable insights in computer vision. I'll see you in the next episode.